Bismillahirrahmanirrahim. Assalamu alaikum, my dear students. I'm Dr. Aisha Rashid. Today I am here with a new lecture naming as Vernier Caliper. I think you people are familiar with this instrument. Here it is shown in the picture. This is a tool for the measurements. This is called as Vernier Caliper. We will discuss in detail this vernier caliper in upcoming slides. Today's discussion will be covered up under lecture 6. So here is the vernier caliper. We will see its history. If we talk about the vernier caliper, it was firstly invented in 1631 by a French mathematician named as Pierre Vernier. After his name, Vernier, this instrument or this tool was named as vernier caliper. So vernier caliper's introduction is here. Like various micrometer, screw gauge, or various measuring tools, vernier caliper is also a measurement tool. We can take various kind of measurement by this vernier caliper. And what is the advantage of different kinds of measurement taking up by this vernier caliper? This has the accuracy within 0.001 of an inch or 0.02 of a millimeter. Or in other words, you can say it is used to make very precise measurements, which cannot be accurately measured from a regular scale or regular meter which we are using. So this is a special tool, a special scale which is designed to measure various diameters, various lengths with the very much precision and accuracy. Error ratios are very much lower by using this tool, this vernier caliper. So if we talk about the types, nowadays in this modern age, there are various types, or you can say there are various improvements in the caliper. Now, three types are used nowadays. The first one and the most commonly used in the lab is the analog vernier caliper. This first one picture is analog vernier caliper. Then the second dial vernier caliper. You can see here in this a dial is fixed on this, which will show the reading, which will show the measurement. The third one is digital vernier caliper. You can see here this digital vernier caliper, the measurement is shown here in the form of digital reading. So if we talk about the parts of a analog, the simple one, the analog vernier caliper which we are going to use in our lab, there are various parts. We will discuss it one by one. You can see here, this one is fixed upper jaw. This one is fixed lower jaw. These two jaws are fixed. These are not movable. These will remain at their place every time. Now here is movable upper jaw. You can slide it backwards. You can slide it forward. This is movable lower jaw. Similarly, this movable lower jaw can also be slide upward, or it can also slide backward and forward. After these jaw, there is vernier scale. This is the scale which is mentioned here. You can see here are basically two types of scale. This one is long one and main scale, and this one is vernier scale. You people must understand two scales are there. This is this one big one, large one. This is just like our regular scale, and we will call it as main scale. This is main scale. The top one, the small one, this is called as vernier scale. Okay, so these two jaws, fixed jaw, movable jaw of top side are known as top jaws, upper jaws, and these are for the measurement of inner diameter of the things. That is why we call them inner jaws. So top jaws are called as inner jaws. while the lower jaws are called as outer jaws. Clear? These jaws are used to measure the outer diameter of any tool or any object. These upper jaws are inner jaws. These are used to measure the inner diameter of any, you can say, the any object. Now this is clear. Main scale and vernier scale. Main scale and vernier scale. So this one whole setup, the top setup, is for internal measurements, and this one whole lower setup is for the external measurements. This one is the log. When you have taken up the diameter, you can log these jaws so that they cannot move and we can find the exact reading. This is fine adjustment screw. If you want to move little bit, you can use this fine adjustment screw. I have told you this is main scale or this is main meter or scale. Okay, this needle like structure you can see here. This is depth rod. If you want to measure the depth of any object, any vessel, you can measure this very easily by this depth rod. Again, the analog vernier caliper parts are clearly mentioned here. Upper jaws for the measurement of inside diameter, lower jaws for the measurement of outside diameter. Vernier scale, this is again vernier scale, main scale, log of the screw. Now here is the depth rod. If we talk about the digital vernier caliper, in case of digital vernier caliper, the parts are the same. Lower jaws for the outside measurement, digital clamp screw. Okay, really sorry for interruption, my dear students. Okay, we were discussing the dial vernier caliper. So the remaining parts are the same. Here is additionally a dial added, dial caliper. Then digital vernier caliper. Again, same parts, main scale, moving scale. In this, there is placed, you can see the digital meter, external jaws, internal jaws. All parts are same, but the reading can be easily taken up by this digital meter. Now the construction. If we talk about the material, if we talk about the construction of the vernier caliper, usually there are uh, various divisions as per manufacturers. Usually vernier caliper is made up of stainless steel. SS stands for stainless steel. Vernier caliper is made up of stainless steel. In digital vernier caliper, display window is made up of hard plastic. If we talk about the digital or dial vernier caliper, all part is made up of steel, but only the dial or the digital meter is made up of hard plastic. Now the special measurements or special definitions on the vernier caliper measurement. The last count. The last count is very much important term when we talk about the vernier caliper. Last count refers to the smallest distance that can be measured using an instrument. Most of the vernier calipers have a last count of 0.1 millimeter. The smallest reading which any tool can measure is called as last count. In case of vernier caliper, the last count is 0.1 millimeter. It means that with the accuracy and precision, a vernier caliper can measure a very much small thing, even it's small, equal to 0.1 millimeter. So the formula for the last count, length of 1 MSD minus length of 1 VSD. So main scale division, MSD is main scale division, and VSD is vernier scale division. You will take the reading on the main scale like it's 8, then you will minus the vernier scale reading like it's 6. So 8 minus 6 reading will be 2. So very much small formula, simple formula. Length of main scale division minus length of one vernier scale division. You will minus one scale of main scale division, and you will take one main scale division, and then you will take one vernier scale division. You will minus vernier scale division from main scale division. This is the formula to calculate the last count. Generally, n divisions on the main scale coincide with n minus 1 divisions on the vernier scale. And one vernier scale is equal to n minus 1 divided by n main scale division. Using the formula for the last count, we can get last count is 1 main scale division minus 1 vernier scale division. So 1 main scale division minus n minus 1 over n into MSD. So this is the total formula. Last count. How you can see this is very much clear. This is the main scale and this is vernier scale. In case of lower jaw, this is main scale and this is vernier scale. You have just to minus this reading from this. So last count is equal to value of one division on main scale, as I have told you in previous slide. Then total division on the vernier caliper. 1 millimeter. If the value of one division on main scale, you can see here, this is 1, 1, 1, 0 से लेके ये पहली लाइन तक, this is 1 millimeter, okay? तो 1 millimeter over total divisions on vernier caliper. Vernier caliper per total divisions 20. So you will divide this 1 minus 20. So the minimum size or minimum count or measurement which can be taken up by this one vernier caliper, this is manufactured by Meher. So this is 0.5 millimeter. So last count varies from manufacturer to manufacturer. हर manufacturer की अपनी specifications हैं. Last count का formula आपका same है. आपने main scale division उसको divide कर देना है total divisions on the vernier caliper. For example, a vernier scale has the length of 9 main scale divisions and it is divided into 10 divisions. Since 9 divisions of the vernier scale coincide with 10 divisions of the main scale. Main scale पे आपके पास 10 divisions हैं, ठीक है, और vernier scale पे आपके पास 9 divisions हैं. तो आप क्या करेंगे? Vernier scale की 9 divisions divided by 10 divisions of main scale. तो आपके पास आंसर आ गया 0.9 millimeter. अब ये आपका VSD है. This is your VSD. Now how you will count the MSD? MSD जो है minimum scale उस पे जो दिया हुआ है that is 1 millimeter. The least length that can be measured from the main scale minus least length यही है ना 1 millimeter minus 1 by 10th centimeter. So the last count is 1 MSD minus 1 VSD. 1 millimeter minus 0.9 millimeter. So this is the smallest count which can be taken up by the vernier caliper. The last count may vary between different vernier calipers. बिल्कुल जैसे मैंने अभी आपको बताया, इस वाले की last count जो है 0.05 millimeter है, और अगर हम ये बात करें कि vernier scale पे 9 divisions हैं और main scale पे 10 division है, तो इस सूरत में minimum measurement जो है वो 0.1 millimeter. Length formula for a vernier caliper. Although last count may vary between different vernier calipers made by the different manufacturer, the length formula for any vernier caliper is as follows. The length is equal to MSR plus VSR into LC, where this MSR refers to main scale reading मेन स्केल पे कितनी रीडिंग आई है किसी चीज को मेजर करते हुए, ठीक है। आपने कोई भी ऑब्जेक्ट प्लेस किया है और उसके बाद आपने रीडिंग देखनी है कि मेन स्केल पे रीडिंग क्या है, सो दिस इज मेन स्केल रीडिंग यहाँ पुट कर देंगे। अब प्लस क्या करना है, VSR वर्नियर स्केल रीडिंग, ठीक है। वर्नियर स्केल फर्ज करें आपका मेन पे था 2 पे, वर्नियर पे था 1 पे, ठीक है, वो रीडिंग लिखते जाना इनटू उस वर्नियर कैलिपर की क्या स्पेसिफिकेशन है, उसकी लास्ट काउंट क्या है 0.1 मिलीमीटर, ठीक है। तो ये आपका फॉर्मूला है टू कैलकुलेट द लेंथ। क्लियर हो गया? मैं फिर बता दूं, लेंथ फॉर्मूला इज MSR प्लस VSR इंटू LC। MSR मेन स्केल रीडिंग, जब कोई भी ऑब्जेक्ट आपने वर्नियर कैलिपर पे प्लेस किया तो मेन स्केल पे क्या रीडिंग है, प्लस VSR उसके वर्नियर स्केल पे क्या रीडिंग है, इनटू लीस्ट काउंट, उस वर्नियर कैलिपर का लीस्ट काउंट स्मॉलेस्ट मेजरमेंट क्या है, ठीक है। नाउ you can see why this vernier caliper is used, how you can use this vernier caliper. Vernier caliper's first use is here. Vernier caliper can be used to measure the internal diameter of things. Like there is a cap, you want to measure the internal diameter of the cap. There is a wide mouth bottle and you want to measure the internal diameter of the bottle. So vernier caliper can be used by using the inner measurement or top jaws. Then it is used to measure the external diameter. कोई नट है, आपके पास कोई स्क्रू है, आपके पास कोई बॉल है, you want to measure the diameter of external diameter of that very object by using the lower jaws के दरमियान में उसको प्लेस करके you can measure the external diameter by the vernier caliper. Okay, you can measure the thickness as well. You can measure the depth by using the depth needle. You can measure the length of any object. Here is the different depictions diagrammatic that how you can measure any object with the vernier caliper. If you consider this, this in green line shows that this is vernier scale, VSD vernier scale, ठीक है। वर्नियर स्केल अगर हम ये इसकी लाइंस काउंट करें 1 2 3 4 5 6 7 8 एंड 9, ये ग्रीन लाइंस आप काउंट करें तो 9 है, ठीक है। जबकि वर्नियर स्केल पे जो है वो सॉरी मेन स्केल पे 10 है, तो हमने कहा था उसको डिवाइड कर लेना है हमने, ठीक है। तो ये हमारे पास इसका आ गया 0.9 जो है वो मिलीमीटर। अच्छा, हाउ टू मेजर by using this vernier caliper. Dimensions: main scale reading plus vernier scale reading into the last count. Length हमने पीछे length का फॉर्मूला पढ़ा है ना, main scale reading plus vernier scale reading into the least count. अब इस पे main scale reading जो है you can find the main scale 0 से लेके 5, तो ये कहाँ main scale पे कहाँ तक आ रहा है 5, ये हमने main scale reading दे दी, ठीक है। प्लस वर्नियर स्केल रीडिंग, ठीक है। अब हमने इसको वर्नियर स्केल जो है वो रीडिंग देनी है। वर्नियर स्केल पे ये लुक दिस इज 1, ठीक है। वर्नियर स्केल पे ये 1 है और मैंने कहा इसका जो है 9/10 करने से 0.1 मिलीमीटर इसका लीस्ट काउंट आ गया। सो द साइज अगर आप ये सारी कैलकुलेट करें 5 + 1 × 0.1, समझ लग गई। 5 जो है मेन स्केल रीडिंग है, 1 वर्नियर स्केल रीडिंग है और 0.1 इसका लीस्ट काउंट है, ठीक है। इसको आप सारे कैलकुलेट करते हैं, सो दिस इज 5.1, ये आपका 5.1, your answer is 5.1 millimeter. Clear? Now the handling, how you handle this vernier caliper. By focusing on this picture you can understand, आपने जो भी ऑब्जेक्ट लेना है उसका एक्सटर्नल डायमीटर अगर चेक करें तो उसको इस ऑब्जेक्ट के जॉस के दरमियान रखना है, यहाँ से आपने उसको थंब से टाइप कर लेना है और स्केल से रीडिंग पढ़नी है। रीडिंग में आपने सिर्फ ये पढ़ना है मेन स्केल पे ये कहाँ आ रहा है और वर्नियर स्केल पे इसकी रीडिंग क्या है, ठीक है। और अगर यही आपने इंटरनल डायमीटर लेना हो इस होल का तो यू विल यूज द इनर जॉज. Now taking various measurements. How to take it, पूरा procedure है. First of all, first find where there is an error on the caliper or not. There are various errors, zero errors, positive error, negative error. We will see in the next slide. So first you have to show is there any error or no error. ठीक है, zero error है कि नहीं है, बेहतर है कि ना हो. अगर zero error है तो उसको आपने उसमें से माइनस करना होता है. First of all, see for the error. ये पहला स्टेप. Second, find its least count. आपको जीरो एरर पता होना चाहिए, उस टूल का, उस वर्नियर कैलिपर का लीस्ट काउंट पता होना चाहिए. Now place the object between the appropriate jaws. If you want to measure the outer diameter, you have to use the lower jaw. If you have to measure the inner diameter, you have to use the inner jaws. Top jaws, sorry, or on the depth rod according to the measurement. Which measurement you want, you must use the proper tool. The reading of the main scale, that is main scale reading, which is to the left of the zero of vernier caliper scale, is the main scale reading. On the left side, this is main scale reading. Now look up for the number of divisions on the vernier scale, which exactly coincides with any of the main scale reading. This is the vernier scale reading. Clear? ऑब्जेक्ट आपने प्लेस किया जॉज में, उसके बाद आपने मेन स्केल रीडिंग पढ़नी है. मेन स्केल रीडिंग कौन सी है? विच इज ऑन द लेफ्ट साइड ऑफ वर्नियर स्केल. वर्नियर स्केल के लेफ्ट साइड वाली रीडिंग आप पढ़नी है, वो मेन स्केल रीडिंग है. और जो एक लाइन वर्नियर स्केल की और मेन स्केल की आपस में मैच कर रही होगी, कंसाइड्स, जो एक मैच कर रही होगी, दिस दैट इज वर्नियर स्केल. ठीक है. The length of the object is calculated by using the formula same MSR plus VSR into the least count. If there is an error in the vernier caliper, positive error थी, negative error थी, according to that you have to either add or subtract depending upon the error type. Now here are the errors, very good depiction, diagrammatic depiction. There are three types of error. Zero error, vernier scale 0 and main scale met each other. In this case there is no error. This is called as zero error. ठीक है, ये पहले को अगर आप देखें, वर्नियर कैलिपर विदाउट एनी एरर, जिसे हम कहते हैं जीरो एरर. ठीक है, कोई एरर नहीं है. वर्नियर स्केल और मेन स्केल दोनों के जीरोस आपस में मैच कर रहे हैं. ठीक है. देन देयर कम्स द पॉजिटिव एरर. वर्नियर स्केल 0 is after main scale. Vernier scale 0 is after main scale 0. You can see here, ये vernier scale है, नीचे वाला जिसके 9 divisions है. ठीक है, इसका 0 जो है वो main scale के 0 के बाद है. This is called as positive error. इस केस में जब आप रीडिंग लेंगे तो आपको ये ऐड करना पड़ेगा. ठीक है, correcting actual reading minus एक्चुअल रीडिंग माइनस एरर, उसमें से एरर की वैल्यू आपने माइनस करनी है. ठीक है, क्योंकि ये इतना आपका ऐड हो रहा है. देन नेगेटिव एरर, वर्नियर स्केल 0 इज बिफोर मेन स्केल. देखिए, मेन स्केल के 0 से पहले है. सो इसकी करेक्शन क्या होगी? एक्चुअल रीडिंग में आप ये रीडिंग ऐड कर देंगे, ये एरर ऐड कर देंगे. सो दिस वाज अबाउट द एरर. नाउ द वेरी लास्ट हेडिंग, स्टोरेज. Okay, when we talk about the storage of the vernier caliper, avoid direct sunlight so that there may be any rust or any destruction. Low temperature, high temperature and high humidity. So any extreme conditions like sunlight, very low temperatures, very high temperatures or high humidity, all these things are very much drastic or damaging for the vernier caliper. Do not leave the jaws of the caliper completely closed during the storage. They shouldn't be completely closed. It will also spoil your tool. So these things must be noticed when we are going to store vernier caliper after taking various readings. Now we have said that according to manufacturer, least count varies, or you can see various differences can be there. So the various manufacturers are here: aerospace, Mutotoyo Aerospace, Mutotoyo Aerospace, Mutotoyo. These two famous manufacturers are here. These provide the vernier calipers with the length even 150 millimeter. Uh, there are analogous type, digital type, and dial type. Various prices are there in rupees. So thank you very much, my dear student. This was about today's lecture. I hope you have enjoyed a lot. This was very interesting or very practical lecture. If you people have any type of query, suggestions, or anything is not clear, you are most welcome to ask during your live session. So nice of you for your cooperation. Thank you so much.